Children, in this video we are going to discuss set operations. So it's an important area. So you have to understand what are the set operations are there, so how we can find those things. First one, complement of a set. The complement of a set is the set of all elements of U. That is the universal set we discussed in the previous video that are not in A. It is denoted by A complement, A dash, or A power C, that is A complement. Okay, children? In symbols, A dash is equal to X such that X belongs to U, comma, X does not in A. The element must be in U, but not in A. So here we can go for Venn diagram for complement of sets. See here, Venn diagram for complement of a set. This is A set. Okay, children, this is A set. A dash. A dash is other than A. That is this portion outside the circle. Okay, children. Here U indicates the universal set. Dear children. Not within the circle, only outside the circle. The first diagram represents A and the second diagram is A dash. Suppose you are taking A dash whole dash is equal to A itself. That is the notes. Just you remember this. The first one, A dash, the whole dash is equal to A. U complement. U complement means what? Except the universal set. Nothing will be there. So that is empty set. Like that, the third one, complement of empty set is universal set. Just you remember that. Suppose let U is equal to 1, 2, 3, etc. up to 10. And B set is equal to 2, 4, 6, 8, 10. Therefore, B dash will be equal to other than B set elements. That is 1, 3, 5, 7, 9. This is the complement of B. Clear, children? Next is union of two sets. The union of two sets A and B is the set of all elements which are either in A or in B or in both. It's denoted by A union B and read as A union B. In symbol, A union B is equal to set X such that X belongs to A or X belongs to B. Here I like to give you an example. If A is equal to 1, 3, 5, 7, 9 and B is equal to 2, 4, 5, 6, 8, 9. Then A union B is equal to, we have to take both the sets together, which may be from A or B. So while taking the sets together, we are getting 1 is there, then 2, then 3, 4, 5, 6, 7, 8, 9. So I can write etc. 9. Or otherwise, you can write all the entries 1, 2, 3, 4, 5, 6, 7, 8, 9. But the basic condition is we are not supposed to repeat the entries. Okay, children. The union of two sets can be represented by Venn diagram as given below. See here, set A and B have common elements, which means is joint set. Okay, children. So union of two sets, that is, we are going to shade for A union B. So A union B means we have to shade both the sets, is both the circles. Okay, children. This is A union B. So if it is disjoint sets, that is the second one, in that case you have to shade A and B. Clear, children? Both represents A union B, but the first one is the example for joint sets, and the joint sets are overlapping sets. Second one is disjoint sets. Now we are going to discuss some results based on union of sets. First one, A union A is equal to A itself. So both the sets are same. So you will get A itself. Next is A union empty set. So that time also we will get A. The third one, A union universal set. A is the subset of U. Universal set is the bigger set. Okay, children? While taking the union between A and U, the result will be U itself. Okay, children? Where A is any subset of universal set U. Next one, A contained in or equal to A union B and B contained in or equal to A union B. What is the meaning of that? A and B are subsets of A union B. The last note, that is A union B is equal to B union A. That is union of two sets is commutative. So commutative property is true in union of sets. Next is intersection of two sets. The intersection of two sets A and B is the set of all elements common to both A and B. It's denoted by A intersection B and read as A intersection B. In symbol, A intersection B is equal to set X such that X belongs to A and X belongs to B. Okay, children? Just you remember that intersection means you have to take the common elements. If A is equal to 2, 3, 4, 6 and B is equal to 1, 3, 5, 6, then A intersection B is equal to, you just see the common entries, that is 3 is common here, then 6 is common. Very clear, children? Therefore we are getting 3, 6 is the answer. So here the common elements you have to take for intersection of two sets. Next one, we have to shade the Venn diagram for A intersection B. That is the common portion, that is this is the common portion for A circle and B circle, or A set and B set. This is the required shaded portion. Here just you see the notes. A intersection B. Common for A and A is A itself. Second one, A intersection null set is equal to null set. Second one, A intersection universal. So the common for A and universal set is A. Since A is the subset of universal set U. The fourth one, A intersection B is the subset of A, and A intersection B is the subset of B. So it's very clear that A intersection B will be the subsets of A and B. Next one, A intersection B is equal to B intersection A. So it's very clear that intersection of two sets is commutative. Listen, children. When B is the subset of A, that is the proper subset of A, the union intersection of A and B are represented in the Venn diagram. So just you see that if it is the proper subset, you have to draw the diagram within the A circle. Okay, children? So the B set will be within A set. Very clear. So we are getting the intersection and union, they are marking there. The shader region is A union B. That is equal to A itself. Its union. That is, union means A and B together. Okay, children. Next is A intersection B. Common for A and B. That is B itself. Clear, children? If B is the proper subset of A, which can be drawn like the first diagram, then the second diagram is A union B is equal to A. Okay, union of both the sets. The third one is A intersection B is B set. Here, if A and B are any two non-empty sets such that A union B is equal to A intersection B. Clear, children? If A and B are any two non-empty sets such that A union B is equal to A intersection B, then A equal to B. If A is equal to B, only in that case, A union of B is equal to A intersection of B. Next one, let N of A is equal to P and N of B is equal to Q. Then minimum of N of A union B. Minimum of N of A union B. That is the maximum of P, Q. Okay, children. So how we are getting this one? Just I'll give an example here. Suppose A is equal to 3 elements A, B, C. B is equal to A, C. So while finding, then A union B will be equal to A, B, C. Am I right? So it's very clear that minimum of A union B, N of A union B is maximum of P and Q. That is, in A set you have 3 elements, in B set 2 elements. Maximum of 3 and 2 is 3. Therefore, we are getting N of A union B is equal to 3. Okay, children? That is maximum of 3 and 2. Next one, the maximum. This is the minimum of A union B. Next is maximum of A union B. For that, I am giving one example. B, A is equal to ABC, B is equal to DE. Then it's very clear that A union B is equal to A, B, C, D, E. So now n of A union B is 5. Okay, children. So the maximum of n of A union B value will be P plus 2. That is 3 plus 2 here. It's 5. Next one, you can go for minimum of n of A intersection B, which is 0 in the B case. You just consider the B case and you take the intersection. Nothing is common there. Therefore, n of A intersection B is 0. So the maximum of n of A intersection B is the example from the A part. A is equal to ABC and B is equal to AC. Then we are getting minimum of P and Q. So in that case, we'll get, just I'll write here, A intersection B will be AC. So n of A intersection B is 2. That is minimum of 3 and 2. Okay, children, please go through this. In that case, you can understand easily. Next one. Difference of two sets. Let A and B be two sets. The difference of sets A and B is the set of all elements which are in A but not in B. It's denoted by A minus B or A difference B and read as A difference B. In symbol, A minus B is equal to set X such that X belongs to A and X does not belong to B. The same thing, B minus A means it should be in B but not in A. Okay, children, just we can see an example. Let A is equal to A, B, C and B is equal to B, D, E. Now I am taking A minus B. If you want to find A minus B, that is A difference B, in that case, you have to take off the common element from A. Here, the common element is B. Clear, children? So, X of B, I have to write A, comma C and B minus C. Now, you have to take B minus A. And B minus A is equal to, now the result must be from B. You can take out the common element. Here again B is common. X of B, you have to write the rest of the elements. That is B comma A. This is B minus A. You must know the difference between A minus B and B minus A. Clear, children? So also you must know that always A minus B intersection B minus A will be null set. Okay, children? No common element will be exist in A minus B and B minus A. Next notes, just you go through this. A dash is equal to U minus A. Okay, from the universal set you have to subtract A, that is A dash. A minus B is equal to A intersection B dash. A minus A is always null set. A minus null set is equal to A. A minus B is equal to B minus A. If both are equal, then A must be equal to B. Okay, children? Then the last one, A minus B is equal to A and B minus B is equal to B if A intersection B is equal to null set. Okay, children? If there is no common element for A and B, then A minus B will be equal to A and B minus A will be equal to B. This we can see in Venn diagram for set difference. A minus B, first we are finding, that is this shaded portion. Okay, children, that is this portion. Then B minus A is this portion. From B, you have to take the common element of A. Just you have to cut the A part from B. Then if it is disjoint sets, A minus B means B should be removed from A. You will get the full A. Clear, children? The Venn diagram also you must know. Next is symmetric difference. The symmetric difference of two sets A and B is the set A minus B union B minus A. It is denoted by A delta B or asymmetric B. Asymmetric B is equal to set X such that X belongs to A minus B or X belongs to B minus A. Just we can discuss with one example. Let A is equal to alpha, beta, gamma and B is equal to alpha, delta. Okay, children. Now you can find A minus B. That is equal to, you are getting A minus B means what? You have to take off the common element from that. Here the common element is alpha. So you can take off that alpha from A. That is beta, comma, gamma. And B minus A you have to find out. B minus A you have to take off common element from B. That is only delta. Therefore, A symmetric B is equal to A minus B union B minus A. That is equal to beta, comma, delta union delta. That is beta, gamma, delta. This is the required symmetric difference between A and B. Just you compare A and B, easily you can write if they are asking the same question in objective. See, you observe A and B, the symmetric difference is nothing but you have to take off alpha is the common element from A and B. Rest is the answer for symmetric difference. Okay, children? Now, what is A minus B intersection B minus A? Already I said it's a null set. Okay, children? Now we can discuss asymmetry B through Venn diagram. First, we have to find out A minus B. This is this shaded portion. Then B minus A, this shaded portion. Now you have to take union between first two diagrams. So you are getting this part and this part together. This is asymmetric B. Clear, children? Now we can move on to the notes. In the note, asymmetric A is null set. Already I explained. You have to take off the common element from A and B. That is symmetric. You just take off the common elements from A and A. So nothing will exist after taking off common elements. That is null set. Next one, A symmetric B is equal to B symmetric A, which is commutative always. Already we discussed union is commutative, intersection is commutative. Now, along with that, you can add A symmetric B is equal to B symmetric A. Therefore, symmetric difference is also commutative. Then the third note, A symmetric B is equal to set X such that X belongs to A union B and X does not belongs to A intersection B. The same thing they given in another way. In the fourth note, A symmetric B is equal to A union B minus A intersection B. All these notes you have to make it thorough with this.